I think the most appropriate way for me to demonstrate my video course to you is for me to make one last video. It's not hard to do. Set up and tear down take about 30 seconds. My setup is on the screen for you to see right now. One thing this course has taught me is how to be comfortable in front of a camera and on a mic. It's also taught me all about video editing and planning ahead, so I can talk about images on the screen in the script I write days or, in some cases, even weeks before I do the recording. Oh yeah, and I've learned a lot about electronics too. For today, I've put together a compilation of my 5 favorite moments from the course. 4 of them have to do with the end results of lessons, so you'll get a glimpse of how neat some of the things we build are. And I've also tried to include examples of my teaching so you can get the whole course experience without dedicating hours to actually doing the course. The first thing I'd like to show you is a clip from Unit 3, Lesson 2, which is a lesson about making an LED blink with code. I know it doesn't sound like much, but it's the first coding experience that the student gets, and it does come with some instant gratification. Hopefully, you'll be able to see how I simplify and explain all the programming that's taking place. Finally, on the next line, get rid of your indent and type loop, then hit enter again and type end to signify the end of your program. That's it. You will have a blinking LED. Now, all we have to do is run it. You've already got the basic stamp plugged in, so all you have to do is go up to Run, Run. If you're so inclined, you can also press the F9 key. If all has gone well, your LED will start blinking just like mine is right now. Yay! That's pretty sweet. The next clip I'd like to show you is from the very last lesson in the course, Unit 5, Lesson 3. It's about making a servo tester, which is a device that tests servo motors to see if they work properly. You can see servos in everything from model airplanes to robotic arms. They're actually fairly common motor devices. The last lesson requires all the knowledge that the students accumulate throughout the course, and the video is pretty long, so we'll just skip to moving the servo at the end, which is the really cool part anyway. Go ahead and run your program now. My personal favorite lesson from the course is about making a die roller for a game like Monopoly. It's so cool that I had to share it with you. It uses a little digital display and the push button, and it displays random numbers on the display from 1 to 6. The numbers change really fast when you hold the button down, so it's almost like you're really rolling a die, but not quite. Anyway, check it out. That's all the code there is to it. Go ahead and plug your battery in and hit F9 to run the code. Let's go for a spin. Now, I don't want you to think my course is all fun and games, because believe me, there are conceptual and mathematical pieces that students have to understand before they can start on the cool projects. I've sat through boring classes where the teacher just gives us notes in a monotone voice for an hour and a half. So I've tried to spice things up a little bit when I can. The clip you're about to see is from Unit 1, Lesson 3, and it explains Ohm's Law with the help of the RMC kitchen. Current's evil twin is called resistance. Resistance is just opposition to current. Just about everything has some resistance. Wires, LEDs, resistors, or anything else current passes through. If you imagine the wires that electricity flows through as a water pipe, you could think of current as moving water. And resistance is some kind of obstruction in the pipe. The more resistance, the less current. The more current, the less resistance. Generally, conductors, like metal, will have a much lower resistance than a resistor like glass or plastic. The unit for resistance is the ohm. So I just got done telling you that everything has resistance. And since resistance opposes current, that means, well, nothing wants electricity to flow. So why does it happen in the first place? It's due to a phenomenon known as voltage. Voltage is the pressure in the water pipe. There are a lot of terms for voltage: potential difference, electromotive force, electric potential, and electrical pressure, just to name a few. Voltage arises when there is a charge. The universe wants everything to just equal out and remain neutral, so charges will flow until that happens. Voltage is the driving force behind that flow of electricity. A very smart guy named Ohm figured out that voltage, current, and resistance are related and expressed it with the formula V equals IR, where V is the voltage in volts, I is current in amps, and R is the resistance in ohms. We later apply Ohm's law to circuit diagrams, so don't think for 1 second that those kids are just getting a formula for no reason. Anyway, I've got one clip left to show you. You might have noticed the annoying beeping every 1 to 4 minutes throughout this entire presentation. I don't know anything about it, but I do know that in my course, the students learned how to make a copy of ThinkGeek's Annoyatron, which is a device that beeps randomly every 2 to 8 minutes. Now, I changed mine to beep every 1 to 4 minutes and play more sounds, just to be even more annoying. But I gave the students some homework at the end of that lesson. That lesson was to use the Annoyatron for the forces of good. So here's my idea of using the Annoyatron for the forces of good. Your homework is to use your new toy for the forces of good, like I am. Okay, time to use the Annoyatron for the forces of good.
You making that beeping noise?
No.
No. Why are you smiling?
So I guess this video lets the proverbial cat out of the bag here. I guess it also ends my Annoyatron days here at RMC. Don't worry, I didn't actually leave it in Everett's office. It never beeped. He wasn't there on the day I did that. So, Everett, I would never do that to you. Anyway, if you hear random beeping, I guess you know whose fault it is now. That's about all there is to my course, though. A lot of programming, a lot of teaching, and a lot of tinkering. I'd like to sincerely thank RMC for the opportunity to develop this course. For me, it was an extremely enriching experience, and I learned more about more things than I ever would have imagined. Thank you to everyone for 2 incredible summers.